Welcome back, class. In an earlier lesson, we learned how to solve quadratic equations by using a technique called taking the square root of both sides. Today we're going to learn about quadratic equations that look like you could solve them that way, but aren't quite what they might seem.
So, they're kind of quadratic equations in disguise?
Sure, Bones, you can think of them that way.
I love disguises! Halloween is my favorite holiday because I get to wear a disguise. A costume.
Halloween is everyone's favorite holiday at this school. We're monsters.
Sometimes my disguises are so scary that even other monsters are scared of me.
Gee, Bones, you're so nice that I don't think anybody could be scared of you.
Sorry, it's a hand-me-down from my dad.
Can anyone recognize me in my disguise?
Class, I like your costumes, but let's focus on our quadratic equations in disguise. Here's what I'm talking about. In our earlier lesson, we said that we were going to need more than one way of solving quadratic equations, because quadratic equations come in different shapes and sizes. So the first technique we learned was called taking the square root of both sides. It worked like this. Quadratic equations always have an x squared in them. So in order to solve for plain old x, which is what we want, we need to get rid of the exponent, the squared, on that x squared. The tool we use for that is taking the square root. Taking the square root of a number is the opposite of squaring that number. Square roots and squares cancel each other out. So if we start with an equation like x squared equals 64, we take the square root of both sides. The square root of x squared equals the square root of 64. On the left side, the square root and the squared cancel out, leaving us with plain old x. Now we just solved the right side, the square root of 64. We just have to remember that when we take the square root of a positive number like 64, there are two answers, not just one. Positive 8 is one of those answers, since 8 times 8 equals 64. But the square root of 64 is also negative 8, because negative 8 times negative 8 gives us positive 64. So x equals 8, and x equals negative 8. There's one last thing that we learned in our earlier lesson. Taking the square root will work even when we have an entire quantity squared on one side of our equation. For instance, let's look at x minus 3 squared equals 25. On the left side, we don't have x squared by itself. We have an entire quantity squared, the quantity x minus 3 squared. But we can still take the square root of both sides. We get the square root of x minus 3 squared equals the square root of 25. On the left side, the square root and the squared still cancel each other out, so the left side of our equation becomes x minus 3 by itself. On the right side, we have the square root of 25, which is positive 5 and also negative 5. So we have x minus 3 equals 5, and we also have x minus 3 equals negative 5. We just solve for x in each equation by adding 3 to both sides, and we get our two answers. X equals 8, and also x equals negative 2. Okay, the reason I reviewed all of that is because in today's lesson, I warned you that some quadratics look like they could be solved this way, but they can't. These equations aren't what they might seem. As Bones said, it's almost like they're in disguise. Let's see an example. Here's the quadratic equation x squared plus 16 equals 0. You might think to yourself, hey, maybe I could solve this by taking the square root of both sides. On the right side, the square root of 0 is just 0. So all I have to do is figure out the left side, the square root of x squared plus 16. And that is where you might run into some trouble. Because what is the square root of x squared plus 16? When we look at x squared plus 16, we notice that it's what we call the sum of two squares. X squared is a variable squared, x times x, and 16 is a number squared, 4 times 4. We're just adding two things together that are both already squared. So you might think that x squared plus 16 is really just the quantity x plus 4 squared. Then we could take the square root of both sides, The square root of x plus 4 squared would be plain old x plus 4, and our equation would become x plus 4 equals 0. X would seem to be negative 4, and we would seem to have solved our quadratic equation. But this is the wrong answer. X is not negative 4. I did something wrong here. Did anybody see what my mistake was? It happened when I looked at x squared plus 16 and decided that two squared numbers added to each other, the sum of squares, was really just the same as the quantity x plus 4 squared. That seemed like it made sense, but it was wrong. So this is an example of what I meant when I said that some quadratic equations are not what they look like. When we see a quadratic equation that's the sum of two squares, meaning a variable squared added to a number squared, it can mislead us into thinking we can factor it easily, but we can't. X plus 4 squared is not the same as x squared and 4 squared added together. What is x plus 4 squared?
X plus 4 squared really means x plus 4 times x plus 4. So we need to use our FOIL technique. X plus 4 times x plus 4 gives us x squared plus 4x plus 4x plus 16. The 4x plus 4x in the middle adds up to 8x. So we have x squared plus 8x plus 16. Is that right?
Excellent, Codette. When we do things the right way, using our FOIL technique, we see that x plus 4 squared actually has a plus 8x in the middle that we didn't expect. It's not just a squared variable plus a squared number, like x squared plus 16. That means we have to be careful when we take the square root of a quadratic equation. The technique of taking the square root of both sides works really well as long as we use it correctly, but it's definitely not going to work if we think the square root is something that it really isn't. We hoped that our equation was the same as x plus 4 squared, because then we could use our technique of taking the square root. But we were wrong, and it gave us the wrong answer.
I think I get it, Mr. C. But what if it had been x squared minus 16 instead of x squared plus 16? You keep saying that x squared plus 16 won't work that way, so would it work if we had subtracted instead of added?
Great question, Ruby. Let's try it. If we have x squared minus 16, we might think, this sure looks like I could factor it as x minus 4 squared. But we have to remember that x minus 4 squared actually means x minus 4 times x minus 4, so we need to use our FOIL method. We can't just square the x, then square the 4, and then keep the minus sign that we started with. When we FOIL, we see what this really is. It's x squared minus 4x plus 16. Those two middle parts, minus 4x, become minus 8x. So this is x squared minus 8x plus 16. And is that the quadratic expression we were expecting to see?
Negative. We were expecting the quadratic to be x squared minus 16. But the correct answer, when we use the FOIL method, has a minus 8x in the middle. We were not expecting that. Our correct answer also has a plus 16 at the end, not the minus 16 we were expecting. These two are definitely not the same.
Well done, V9. So we saw earlier that x plus 4 squared is not the same as x squared plus 16. Now we're seeing that x minus 4 squared is not the same as x squared minus 16. These two quadratics looked like we could factor them into perfect squares, but we couldn't. And that means, unfortunately, that our technique of taking the square root is not going to work very well on these. In other words, if we start with a quadratic equation that is the sum of two squares, or the difference of two squares, don't be fooled. Now, class, I don't want you to think that today's lesson is just about things you can't do, and equations you can't trust. We're about to see something pretty cool that we can do, and it's right in front of us. We just haven't tried it yet. We FOILed x plus 4 squared, and we FOILed x minus 4 squared. But what if we took one factor from each of those and multiplied them together? Wendigo, could you please FOIL x plus 4 times x minus 4 for me?
We get x squared plus 4x minus 16. In the middle, I see that we have two amounts that we can combine. a plus 4x and then a minus 4x. When I combine them, I get... Wait, that is not what I expected, teacher.
Wendigo, explain to the class what you just noticed.
In the middle, the plus 4x and the minus 4x balance each other out. They cancel each other, as you would say. This leaves us with no x's. Therefore, x plus 4 times x minus 4 is simply x squared minus 16.
And does x squared minus 16 look familiar?
Hey, look at that! We've seen that guy before.
X squared minus 16 is the same quadratic expression we saw earlier. It's the one we thought we could factor as x minus 4 times x minus 4, until we actually foiled it and saw that it didn't work. Now we've just seen the right way to factor it. X squared minus 16 is x plus 4 times x minus 4. It's not a perfect square because the two factors are slightly different. One has a plus while the other has a minus, so using our technique of taking the square root won't do anything useful here. But this is going to be very useful in other quadratic equation problems. In other words, we've just learned that when we have the difference of two squares, meaning a squared variable minus a squared number, it can be factored. And better yet, the factors follow a pattern. The factors will be x plus the square root of the number at the end times x minus the square root of the number at the end. X squared minus 16 became x plus 4 times x minus 4. Let's try an example. If we have the quadratic x squared minus 25, how would we factor it using this same pattern?
X squared minus 25 is a squared variable minus a squared number, so it's a difference of squares. That means we can use the pattern you just taught us. The first factor will be x plus the square root of 25, and the second factor will be x minus the square root of 25. So that would be x plus 5 times x minus 5, right?
Good, Codette. Here's a harder one. Tom, you've been awfully quiet today. Could you answer one for me?
Oh, Mr. Caldwell, maybe it is better if you ask Codette again. She is very good at knowing right answers. Sometimes I am very good at knowing only wrong ones.
Give it a try, Tom. Don't be afraid. Making mistakes is one of the best ways to learn. Try to factor this one. 2x squared minus 32.
Mr. Caldwell, this question is impossible. Do I look like a rocket scientist, or a brain surgeon, or a nuclear philatelist?
What is a nuclear philatelist?
Tom, let me give you a hand. This is another expression that's trying to mislead us. It looks hard, but it's actually easier than it seems. Let's start by dividing both parts of it by 2. In other words, factoring out a 2, a step that you learned earlier in algebra. It works with simpler equations, and it works with quadratic equations too. When I factor out a 2, I get 2 times x squared minus 16. Does that look more familiar, Tom?
Oh, I think I have made a very big discovery, Mr. Caldwell. You will not believe it, but if you look very carefully at what is inside the parentheses, it is x squared minus 16, which we have seen before. It is what we math geniuses call the difference between two squids.
The difference between two squares.
Yes, that is what I said, the difference between two squares. So it can be factored using the pattern that you taught us. It is x plus 4 times x minus 4.
That's right, Tom. Well done. So we already knew that x squared minus 16 could be factored as x plus 4 times x minus 4, because it's the difference of two squared numbers, the difference of squares. But we didn't know that x squared minus 16 could show up in a costume, doubled or tripled or multiplied by some other number that makes it hard for us to tell what it really is. We just learned that sometimes, in order for us to see the real equation that's hiding before our eyes, we have to factor out a number that the parts all have in common.
But how are we supposed to know when we should do that? Tom didn't know when he was supposed to factor out a number. I wouldn't have known either.
Good question, Ruby. The best clue is when our quadratic equation starts with 2x squared, or 3x squared, or some other amount of x squareds, other than just one single x squared. It's much easier to factor a quadratic if it starts with just one x squared, so it can be a good idea to try to factor out whatever number the x squared is being multiplied by. It's probably easier to show you if we do an example. V9, how do we factor 3x squared minus 12?
3x squared minus 12 does not appear to be easily factored. However, I will not be fooled by these quadratics again. The 3x squared is a disguise that is trying to confuse me. I will take my revenge by dividing everything by 3 to remove the disguise. This gives me 3 times the quantity x squared minus 4. Ha ha, now I see your true identity, quadratic expression. Inside the parentheses is x squared minus 4, which is a squared variable minus a squared number, so it is the difference of two squares. Therefore, it can be factored as x plus 2 times x minus 2. Our final answer is 3 times x plus 2 times x minus 2.
Excellent, V9. That's very well done. And now, class, let's make sure we remember how to finish solving for x. Once we've done all of this work to get a nice factored quadratic, like the one V9 just figured out, what's our final step? If I set this expression equal to 0, so that we have the equation 3 times x plus 2 times x minus 2 equals 0, do you remember how we solve for x?
Teacher, you have taught us that in a factored equation like this, we only need to find a number that makes any of the factors equal to 0, because 0 times any other factor will still give us an answer of 0. Therefore, we need to figure out what numbers we can plug into x plus 2 and x minus 2 so that either of them would equal 0.
What I believe the Yeti, the Wendigo, is trying to say is that our first factor is x plus 2, so we can plug in negative 2 for x, and negative 2 plus 2 will equal 0. Our second factor is x minus 2, so we can plug in positive 2 for x, because positive 2 minus 2 will equal 0. This means that we have two answers, x equals negative 2 and positive 2.
That's right, both of you. Once we've figured out what the factors of our quadratic equation are, like x plus 2 and x minus 2, we can solve for x by setting each factor equal to 0. We'll end up getting two answers, and either answer will work, so both of them are correct. On a test, we would need to write down both of them. Good job today, class! Let's review what we learned. The first technique we learned for solving quadratic equations was to take the square root of both sides. But some quadratic expressions that look like they should have simple square roots, like x squared plus 16 or x squared minus 16, actually don't. A quadratic that's the sum of two squared numbers, like x squared plus 16, cannot be factored as x plus 4 squared. A quadratic that's the difference of two squares, like x squared minus 16, cannot be factored as x minus 4 squared. So these two types of expressions can fool us if we aren't careful. We also saw another disguise that quadratic equations can wear. A quadratic equation that looks like it's going to be hard to solve is sometimes just a simpler quadratic equation multiplied by a number like 2 or 3. All we have to do is divide the whole thing by that number, and we can see the simpler quadratic equation that's inside. In our example of 2x squared minus 32, we factored out the 2 and we got 2 times x squared minus 16. X squared minus 16 is a quadratic we do know how to solve. So if a quadratic equation starts with 2x squared or 3x squared or something else that isn't plain old x squared, try dividing everything by that number and maybe the job will be easier than you thought. Which brings me to the last thing we learned today. The reason we know how to factor x squared minus 16 in that last problem is that x squared minus 16 is what we call the difference of squares, meaning that it's a squared variable minus a squared number. And any quadratic equation that's the difference of squares can be factored using the pattern we learned. X plus the square root of the number times x minus the square root of the number. So x squared minus 16 is factored as x plus 4 times x minus 4. Well done today, class! In our next lesson, we'll learn another technique for solving quadratic equations. I'll see you then!